This is the continuation video of part 7. Here we have 1 coulomb. What does it mean? Here we have kept 6.25 times 10 power 18 protons. It has charge of 1 coulomb. Here we have 6.25 10 power minus 18 electrons here. It has minus 1 coulomb. Okay. Now do one thing. This is also 1 coulomb. Can you now we hold this coulomb at a particular point. Now I bring it this plus coulomb towards this charge. Very difficult to bring it towards this because both will repel each other. It has its field around its charge. It is also having its field around this. See, it's radially outward. This also has a charge. This also is charged like that. Charged like that. What will happen? This both will repel one another. This will repel one another. Okay, this will repel one another. So you should do some work. We should do some work to bring this 1 coulomb towards this point. Right? You must do some work. One should do work to bring it toward this one. Okay, take this case. Here, for example, this is kept here. Okay, you must do work to keep it away from this charge. We must do work to keep away from, to separate it away from charge. So this is called here. This is defined as V. See, this is for example 1 coulomb. One shell is some coulomb. We do some work. We do some work. So the work done on this charge, to bring it into this field. That is called potential. What is the unit of voltage? What is this one? This is called coulomb. Unit of charge is called coulomb. Unit of work is called joule. So one coulomb, if it is 1 coulomb, to move 1 coulomb from a particular point to cross a particular area, cross section, to move 1 coulomb, if it takes 1 joule, that is called 1 volt. Understand? It's called electric potential. What is it is defined like that? Electrical potential energy. This is force. This is distance. Work is equal force time distance is work. So this is work done per charge. Work done per charge is called voltage. Okay. Now let me explain more about the voltage. Take the case of now I am going to compare the water flow. We take the analogy of water flow. This tank 1 has completely full of water, filled with water. It is empty. So rate of flow of water depends on both tank and 1 and 2. Now the flow will be more. Say the flow of water is compared with the flow of electron. Flow of water is occur in the tube, but flow of electron is occurring in the wire. Suppose wire means it is wire. So electron will flow. So if you want to make the electron to flow, here this point should be higher potential. This should be lower potential. See, you compare this one. Now I take 3 points. Point number 1, point number 2, point number 3, point number 4. This point has this water tank. If you keep a hand at this point, it will have more pressure. At this point, pressure will be little less. Pressure will be zero pressure. For example, the unit of pressure is Pascal. Suppose this point has 90 Pascal. This point have 60 Pascal. This have 30 Pascal. This point has 0 Pascal. The pressure is called potential. Now the pressure of water can be compared with the potential. Okay, potential. Potential is ability to do work. Okay, if you want to, you cannot take anything against this one, because everything will push downwardly. Okay, we know this has more pressure, so 90 pascal, 60 pascal, 30 pascal. What about the potential difference? This is called potential. 60 pascal is potential, pressure is potential, pressure is compared with voltage. Okay, what is the difference between this point and this point? This is point number 3, point number 4, point number 3, point number 2, point number 1. What about the pressure difference between point 4 and point 4, 3? 90 pascal minus 60 pascal. The potential difference is 30 pascal. 30 pascal. What about the difference between here and here? 30 pascal. Here, this is also have potential differences 30 pascal. What does it mean? Pressure 3 minus pressure 3 minus pressure 2. What about this and this? Pressure 2 minus pressure 1 is called 30 pascal minus 0 pascal. What about the pressure difference between this point and this point? This point, this point. Yes, this is 90 pascal. This has 30 pascal. What is the difference between this point and this point? That is 90 pascal minus 30 pascal. That 60 pascal. Difference, potential difference is 60 pascal. I think you would have understood the potential difference very well. If the potential difference is more, flow will be more. Flow will be more. Here, what about the flow here? This have very less pressure. Now, if you release it, this have very high pressure. This part have low pressure. So water will flow like that. Flow like that. See, once the water level in this tank acquired up to this level water, this would have decreased. The level would have come here. So there will not be any flow. So at that point, potential difference will be same. If the both tank, this is tank 1, this is tank 2, both have same water. Now you connect the tube across this one. So the pressure of this point and the pressure of this points are equal. Pressure of point A is a tank 1, tank A, tank B. So pressure of tank A at this point, pressure of tank B at these points are equal. So there will not be any flow. So there is potential difference is 0 volt. 0 volt. The unit of potential is volt. Should be given in volt. Potential difference also in volt. Right? Okay. Now you see the next picture. What about the flow here? Flow will be less. Because potential difference is less. 50, this is 0 pascal. 50 pascal, 0 pascal. So less. What about this one? It's very less, because the rate of flow of water depends on water level in the tank 1 and tank 2. This tank 1 and tank 2. This flow will be very less when compared with the tank 2. Okay. Now this is the point D. This is point this point D. This point C. Point B. This is the point A. See, at point A, pressure will more flow. So pressure is high. It has a high pressure. The whole water will put the pressure on this point. So the pressure will be more when compared with the B, C and D point. So more pressure. What about B? Pressure is directly less pressure. What about this point? Very less pressure. What about this point? Pressure is. What about the point D? Very, very less pressure. So flow is based on the pressure. So the pressure is more, flow is more flow. Pressure is less flow. Pressure is very less, so flow is very less. Pressure very, very less, flow is very, very less. Now, this is a 1.5 volt battery. This is a battery. Battery means, this is battery. This is positive terminal, negative terminal. The potential difference between this point and this point is 1.5 volt. 1.5 volt. This is 0 potential, this is high potential, 1.5 volt. What about this one? This is 0 point, this is high potential. Okay. Now I connect this. This is minus, this plus terminal, this minus terminal, plus terminal, minus terminal, plus terminal. Every battery has its own minus terminal, plus terminal. Now I have connected all this in series. What happened? Now I connect a bulb across this point and this point of that bulb. The bulb flow give very dim light. The light is very dim. Now I connect another bulb across this point and this point. See, now you should add the voltage 1.5 volt plus 1.4, 3 volt. What is the potential difference between this point and this point is 3 volt. 3 volt. So this will not be so dim as this bulb. Now I connected another bulb across this point and this point. So what about this is point 0.050 volt, this is 4 volt. So the potential difference is 4.5 volt, 4.5 volt. See, what about this and this point is 4.5 volt minus 0 volt, 0 volt. So this has more power when compared with this one. What about the last bulb? This bulb has, every bulb has two terminal. One terminal connected with the high potential, another terminal is connected with this potential. This is low potential. This is very high potential. This will be very bright when compared with all those things. All those things. But if you connect another bulb like that, this will be dim. This will discharge. This will be this was same flow as like that, because across this point and this point of the bulb is 1.5 volt. Potential difference is 1.5 volt. So it will release the same energy as it release. But whereas this case is entirely different. Bulb number 4 is entirely different. The whole 4 battery will give lot of energy through this, give a lot of work will be done through this lost bulb. I think you would have understood the potential and potential difference very well. I think. Now, next we'll see about Ohm's law. Okay.